How do you derive different equations from a real-life example such as longboarding? Acceleration and velocity are very important to everyday situations. It's a topic that can be applied to any moving object. What we will attempt to do in this video is calculate velocity and acceleration from a starting point at 0.
We set up our experiment as follows. First, we measured an interval of 40 feet so we would be able to find a time for that distance. Second, we measured another distance of 20 feet at the end of our 40-foot interval so we could find a velocity when the initial speed was not 0. And third, we performed our experiment. Why 6 trials? Most skateboarders begin with a push, so starting from 0 is not easy. We noticed a difference of 6/10 of a second between our highest and lowest recorded time. We tried to reduce our percent error by taking multiple measurements. Results. After 6 measurements, we found that our times were much more consistent. Our lowest time was 2.6 seconds, and our highest time was 2.7 seconds. These results make sense because we started with an initial velocity that was non-zero, and because our acceleration was constant.
Now, we will attempt to calculate and compare the velocity and acceleration of each interval. Since acceleration is constant in the ideal setting, the acceleration of interval 2 and interval 1 should be the same. The data we collected for the first 40 feet was 10.6, 10.8, 11.0, 10.6, and 10.8 seconds. The data we collected for the next 20 feet was 2.6, 2.6, 2.6, 2.7, 2.7, and 2.6 seconds. The average of the first 40 feet was 10.8 seconds, the average of the next 20 feet was 2.6 seconds. To calculate the average velocity for the first 40 feet, we use the equation velocity average equals change in displacement over change in time. Then, we use the second equation to determine average velocity in order to determine the final velocity. Velocity average equals 1/2 times the quantity of the initial velocity plus the final velocity. Finally, we use the equation for acceleration. Acceleration equals velocity final minus velocity initial, all divided by a change in time, in order to get the acceleration for the first interval. Then, to find the average velocity and acceleration of the second interval, we use the same equations, except in the second average velocity equation, we use the final velocity from the first interval as our initial velocity for the second interval. This allowed us to calculate acceleration from a non-zero initial velocity. The average velocity for the first interval came out to be 3.7 feet per second, and the acceleration for the first interval came out to be 0.686 feet per second squared. The average velocity for the second interval came out to be 7.69 feet per second, and the acceleration for the second interval came out to be 0.21 feet per second squared. The acceleration of each interval is fairly close, but they are not equal because friction was a major factor in the experiment since the skateboard was in contact with the ground.
Another very interesting aspect of boarding is the use of pumping to accelerate, instead of pushing off of the ground with your foot. Pumping a board is basically leaning forward and forcing the board from side to side. Surprisingly enough, this causes the board to accelerate. It can be explained by imagining the front of the board as a vector. As the front of the board swings from side to side, it creates a series of additional vectors. The derivative of this series of vectors is the angular momentum of the board. If you apply the most pressure to the front of the board when the angular momentum corresponds to the direction that you want to go, in our case, straight forward, and little to no pressure when the angular momentum is on either side of your direction, you will accelerate forwards. In other words, putting pressure on the front of the board only when it is in the middle of its side-to-side swing will cause the momentum to be used to push the board forwards. Due to the irregular surface of the asphalt, the skateboard did not have a perfectly consistent traction and friction each trial, and thus did not have the exact same acceleration each time. This is particularly evident during the first phase of each trial, where the difference between each trial is the largest. As the board reached higher velocities, it tended to ignore the small irregularities of the surface.